Have you ever sat there wondering what an examiner is actually thinking? Well, today we're going to find out. We are diving deep into a full question from the AQA GCSE Physics paper. We're not just going to find the answers, we're going to deconstruct question 7 from the June 2022 exam to show you exactly how to lock in every single mark.
So here's our game plan. We'll start by breaking the question down into its two big topics. First, transformers, and then we'll get into forces and fields. After that, we're going to zoom out and see what this one question can teach us about absolutely mastering the mark scheme. Our mission today is pretty simple. We want to get inside the examiner's head. And to do that, we'll be using the official AQA mark scheme as our guide. Because look, it's not just about what you know, it's about how you show what you know in the exact way that gets you the points. All right, let's jump into the first part of this question. It's all about transformers. We'll start with a pretty basic labeling task before moving on to some crunchier stuff. First up, it's a classic. Label the diagram. You've got to identify parts A, B, and C on this transformer. This is a pretty straightforward test, just checking you know the fundamentals. And here's the answer straight from the mark scheme. Now, pay close attention here. You get 1 mark for identifying both the primary and secondary coils. You don't get half marks for just one. The second mark is for the iron core. It just goes to show precision really matters. Okay, next up we've got a calculation. We're given the input voltage and the number of turns on each coil, and our job is to figure out the output voltage. And remember, for any calculation question, showing your work is absolutely non-negotiable if you're aiming for full marks. So, your very first mark comes from correctly plugging the values into the transformer equation. That means you've got 230 volts for the primary voltage over our unknown secondary voltage, and that equals 200 primary turns over the 1200 secondary turns. Get that down and you're already on the board. And here's the full 3-step process to get all the marks. The second mark is for correctly rearranging the equation to solve for Vs. And that third and final mark? That's for the correct answer, 1380 volts. Follow these 3 steps and those 3 marks are yours. Simple as that. Now we've got a 3-mark explanation. This is where they really test your understanding of the process. The question is how a transformer works, which means you need to describe it like a clear step-by-step story. Okay, here's how you get those 3 marks. First, you've got to say that the alternating current in the primary coil creates a changing magnetic field. That's point 1. Second, this field is then passed through the iron core. And third, and you have got to use this word, the changing field induces a voltage across the secondary coil. Honestly, induces is the magic word here. All right, let's switch gears and move on to the second half of the question. Here, the topic changes from transformers over to the motor effect, specifically the force on a wire that's carrying a current inside a magnetic field. So here's the new scenario. You've got a cable hanging between 2 poles, carrying a 50-amp current, and it's sitting in the Earth's magnetic field. The question is simple. Which way is the force on that cable pointing? This is a job for Fleming's left-hand rule, so get your hand ready. Your first finger points in the direction of the magnetic field. Your second finger points in the direction of the current. And your thumb, well, your thumb shows you the direction of the force. In this case, your thumb points down. That one word is all you need for the mark. And we're back to another calculation. This time, we're going to use the force equation, F equals BIL, to figure out the length of the cable. We've been given the force, the magnetic flux density, and the current. Now, this is a 4-mark question, so there are 4 distinct steps to get them all. First things first, you have to convert the magnetic flux density from microteslas to teslas. Don't forget that, that's your first mark. Then you substitute the values into the equation for the second mark. Correctly rearrange it to find the length, L, for the third mark. And finally, the right answer, 15 meters, gets you that 4th and final mark. Okay, the very last part of this whole question is a 1-marker, and it tests whether you understand the ideal conditions that the F equals BI equation relies on. It just asks for one assumption that you made during the calculation. Now, this is a perfect example of how the mark scheme can be pretty flexible. It asks for just one assumption, but look at this. It actually accepts 5 different, totally valid answers. The most obvious one is that the wire is at a right angle to the field, but you could also say the field is uniform, or the cable is straight. It's a great reminder that sometimes there's more than one right way to get the mark. Okay, let's bring it all home. We have just picked apart a 14-mark question piece by piece. So what's the big lesson here? What's the main takeaway from this deep dive into the mark scheme? Well, first,
Just look at how many core GCSE physics topics were packed into this one question. We've covered how transformers work, electromagnetic induction, two massive equations, and the motor effect. It really shows you how interconnected everything on the syllabus is. So what is the big takeaway? You've got to start thinking of the mark scheme as your secret weapon for revision. It is not just a list of answers. It is a blueprint, a roadmap that shows you exactly how to build your responses to get the maximum credit. So that leaves us with a challenge for you. We've broken this one question down. Now it's your turn. The next time you do a practice paper, don't just check if you got the answer right or wrong. Really analyze the mark scheme. Ask yourself why the marks were given where they were. That right there is the secret to turning a good grade into a great one. Thanks for watching.